Well, what's up guys, and welcome to this video. This is the third video of the series on projectile motion in one direction. So we went over the equations of motion, then we spoke about the importance of direction, did some examples, then we went and did objects being thrown up and returning to their original position. And now we're going to do objects being thrown up and not returning to the same position, the keyword being not returning. Okay, so I actually did this video before, but unfortunately I forgot to record the audio, so the questions are written out, so hopefully it'll be a bit faster. Okay, so let's get into it. So let's just back up and think about some theory here. So the situation that we have here is an object gets thrown up. So we have a ball that gets thrown up, it reaches its maximum height somewhere here, and then goes down again, but it doesn't return to its original position. So it can maybe stop here, or it can go even further beyond the original position and maybe hit the floor or something like that. But as you can see, wherever it ends, whether it's, let's say, 1, 2, 3, 4. Okay, so whether it ends at 3 or 4, it is not at the original position that it was at. It's no longer at the same height as 1. Okay, and just remind you guys on some theory, acceleration in free fall especially, the acceleration is always equal to 9,8 meters per second squared downwards. At point 2, we have the ball being stationary, so the velocity at 2 is equal to 0 meters per second. We know that the velocity at any 2 points that are equal have the same velocity, so 2 points that are at the same height. So let's say we have point 5 here. The velocity at 5 is equal to the velocity at 3 because they are at the same height, but obviously with opposite direction. Okay, and lastly, I just want to remind you that you can, when we're working with the UVATs, we can have situations where we work between points 1 and let's say 5, or we can work between 1 and 3, or any 2 points. We can work between any 2 points as long as we keep the direction correct and we use the conditions for those points. So if I wanted to, I could even work between point 3 and point 4. So you can choose any 2 points and just make sure your UVATs are correct and everything should come out all good. Okay, so let's look at a problem. So example 3. An iPhone is thrown vertically upwards with a speed of 15 meters per second from a building. So I don't know who's throwing iPhones up, but lucky them, I guess, if they've got that much money. So it's been thrown up vertically with a speed of 15 meters per second from a building. It is released from a height of 20 meters above the ground. Okay, so with any of these questions, the first thing you want to do is just draw out a schematic of what's actually happening. So we have a building which is 20 meters high. So we'll take that as the floor. And then what we have is a person throws up their iPhone upwards, then it reaches the top, and it goes all the way down until it finally hits the floor. Okay, so I'm just going to label some points that I think are going to be important. So I'm going to say that's position 1, right at the top is position 2, and finally when it hits the ground is position 3. Okay, so with that said, let's look at the first question, which says determine the time taken to reach the maximum height. Okay, so to reach the maximum height, so I'm going to propose that we use points 1 and 2 because we know some information about point 1 and we know that at point 2 is the maximum height. So let's draw up our UVATs. Okay, so U is our initial velocity, V is our final velocity, A is our acceleration, T is our time, and S is our displacement. Then what I'm going to say is that I am picking upwards as positive because the phone is traveling upwards first, and we know the initial velocity is, from the question, 15 meters per second. The final velocity at the top, V2, is equal to 0 because that is the maximum height. The acceleration is minus 9,8 meters per second squared, and so our time is unknown and our displacement is unknown, and we're worrying about the time. Okay, so from my equation list, I'm going to pick the equation v equals u plus at. Okay, so v is equal to 0 equals u is 15, acceleration is minus 9,8 times t. Okay, so the only unknown here is t, so we can solve for t. So I can say 15 equals 9,8 t. So t is equal to, and if I plug that into my calculator, I get 1,53 seconds. Okay, so the time it takes to go from 1 to 2 is 1,53 seconds. Okay, and with that we answer that question. The next question says, determine the maximum height above the building. Okay, so determine the maximum height that the phone goes above the building and then above the ground. Okay, so two questions in this. Okay, so I've already, the maximum height is going to be between 1 and 2 once again. So my points are going to be between points 1 and 2, and I might as well use the UVATs that I used before. So now I just need to pick an equation. I'm going to pick an equation that does not rely on t or time. Okay, so obviously the reason why I do that is because if I made a mistake in my previous calculation, I don't want to be pulling that through to the next question. So I look for an equation used to figure out the displacement, and I can use the equation v squared is equal to u squared plus 2 times the acceleration times the displacement. Okay, so the final velocity is equal to 0 squared is equal to, we're going to say u squared was 15 squared plus 2 times acceleration, which is minus 9,8, times the displacement, which is the unknown. So what I have is I'm going to have 15 squared over 2 times 9,8 is equal to my displacement. Okay, that's an S. Displacement. Okay, so I can calculate my displacement. S is equal to 15 squared over 2 times 9,8, and that comes out as 11,48 meters. Okay, so that is the displacement from 1 to 2. So that's the displacement above the building. So I'm going to say 11.48 meters above the building. Okay, but now to answer the second part, I want to know how far it is above the ground. So displacement above the ground is going to be equal to what I calculated. So if I look at this, this is the displacement I calculated, which was 11,48, and this distance here is 20. So to get the distance above the ground, I just add these two. So the displacement above the ground is going to be equal to 20 plus 11.48. So that comes out as being 31,48 meters above the ground. Okay, cool stuff. So question C, determine the velocity of the phone as it hits the ground. Okay, so now I'm concerned about point 3. So I might as well pick point 1 and 3 this time, because that makes sense to me. Points 1 and 3. Sometimes you'll pick a point, you could have done between point 2 and 3. You can pick basically any 2 points, but what you want to try and pick is points that you have relative amounts of information about. So if we draw up our UVAT, what we're going to have is our initial velocity, and I'm going to take upwards as being positive once again. Our initial velocity was 15 meters per second. Our final velocity is the unknown, which I'm looking for. Our acceleration is minus 9,8 meters per second. The time is also unknown, and the displacement. Okay, so what is my displacement? If I look at point 1, the displacement from point 1 to point 3, right? I'm going from 1 to 3. So that's 20 meters down. Okay, so that's going to come out as being minus 20. My displacement is minus 20. It's very important that you get this sign correct. Okay, so now that we have our UVATs, it's time to carry out a calculation. So I think we can work with v squared equals u squared plus 2as. Okay, so we're left with v squared equals u squared is 15 squared plus 2 times minus 9,8 times minus 20. Okay, but I obviously want v, so I'm going to square root both of these sides. So if I plug this into my calculator, I get V as equaling square root of 15 squared plus 2 times 19.8 times 20, and I come out with an answer of 24,94 meters per second. Okay, so an important thing to note, NB, with this equation, the answer will always come out as a positive velocity. Okay, the reason for that is because we're introducing a square root sign. Okay, so technically we should be saying plus or minus. And in this case, the answer is minus. So we need to do this by inspection. We need to say that this phone, we know this phone is going down at 0.3. So that means the velocity must be minus, must be downwards. So the velocity is equal to 24,84 meters per second down. Okay, that's very important. Don't get fooled into the idea of thinking that this phone is now moving upwards. We know that it's moving downwards. We need to use some common sense in these questions as well and just make sure that everything makes sense. Okay, and we get on to question D, calculate the total time. Okay, so to calculate the total time, again, I am going to just use the UVATs that I used before because I care about the time taken all the way from point 1 to point 3, right? So yeah, with that said, let's see what equation I can use. I think I can use the equation S equals UT plus a half G or AT squared. Okay, so I think that equation can work. Okay, so my displacement is minus 20 is equal to my initial was 15t, and this time I'm going to have plus a half times minus 9,8 t squared. Okay, so I'm going to move everything to the left hand side of the equation. So I'm going to have 4,9 t squared minus 15t minus 20 is equal to 0. Okay, so now you've got two options. If you have a scientific calculator, you can go ahead and use that to do this quadratic equation. If you don't, then you have to use the quadratic formula to get the answer here. And if we calculate that, we come out with t is equal to, okay, so we should get two answers. So the first answer is 4,07 seconds, or t is equal to minus 1,00 seconds. Okay, obviously one of these answers is not correct. You cannot have a negative time, and so we can just say that the total time is actually equal to 4,07 seconds. Okay, so if you didn't want to use this quadratic equation way, then what you could do is look at the time taken to get from 2 to 3. Okay, so your UVATs, you do UVATs from point 2 to 3, then you'd get that time is equal to some value, and then you'd add that to the time calculated from 1 to 2, which we already did to give you the total time. And you can do that for fun, or maybe not for fun, but just to check your answer, and you should get a very similar answer, somewhere around 4.1 seconds. Okay, there might be some rounding errors, but yeah, so maybe go do that and just see if that works. Okay, so the last question says, draw the velocity time graph and acceleration time graphs. I'm going to actually add something there, and I'm going to say also the displacement time graphs. Okay, so if we start off, let's start off with the displacement time graphs. So displacement is in meters and time is in seconds. Then we have a velocity time graph, v in meters per second, and time in seconds. And finally we have an acceleration time graph in meters per second squared, and time in seconds. Okay, cool stuff. So what does this look like? First of all, we need to pick a reference point. I'm going to pick the reference point as being the ground. So at 0, so at the point 0 is our ground point. So at 0 seconds, we know that the phone is 20 meters above the ground, and we know that at 1.53 seconds, it's at its maximum height, and that maximum height above the ground was 31.5. I'm just going to say 31.5. Okay, so it's right there, and then we know at the final time of 4.07 seconds, it is back at the ground. Okay, so we basically need to join these 3 points, and the question is, how does this look? Okay, so it's going to be not straight line graphs, but rather a curve, because it starts out with a fast velocity, then it slows down until it gets to 0, at which point it starts speeding up again, and it hits the ground at the fastest velocity. Okay, then the next thing we need to do is look at the velocity time graph. So we know, okay, so in this place we've taken upwards as being positive. Okay, I'm going to do the same for the velocity time graphs. I'm going to choose upwards as being positive. So we know that the phone starts off with a velocity of 15 meters per second. At time equals 1.53, we know it goes through the 0 point. And we know that at time equals 4.07, it has a velocity of minus, let's see, 24.84. 24.84. Okay, these graphs are very rough, so you guys should probably draw them a bit better. But okay, so this time we know that the gradient of this graph is also equal to our acceleration, which was a constant minus 9.8 meters per second squared. So we know we have a straight line graph through these 3 points. Okay, so we also know that the gradient was negative, which makes sense because we took upwards as being positive. And finally, we have the acceleration time graph, which is very easy. We know the acceleration was constant, minus 9.8 meters per second squared. So for the entire time period, 4.07 seconds, it was that value. Okay. Also just put in your 0 points. Sometimes you may get marks deducted if you don't. But yeah, so that's the end of this video, guys. I hope you guys found it useful. Let's see what we're doing in the next video. So in the next video, we will do dropping objects from a moving platform. So that will probably be the last video of this series. Yeah, so thanks for watching, guys. I hope you guys found this useful. I hope that you took something away from this. And yeah, just go try this question, and good luck. Thanks for watching.